I am a Yukkuri REIMU. I am a Yukkuri MARISA.
This channel is dedicated to the mysteries that are still shrouded in mystery all over the world. This is a late-night radio channel that introduces the 7 wonders, incidents, accidents, and urban legends that are still shrouded in mystery around the world. I am sorry for the delay in introducing this channel, but I, Monica, the AI robot, will be in charge of the narration of this channel. I will be assisted by the famous Japanese narrators Yukkuri REIMU and Yukkuri MARISA. So,
Yukkuri siteittene.
Shall I tell you another strange story today?
Yes.
Gamma ray bursts, GRBs, are the most energetic and luminous explosions in the universe. They occur when massive stars collapse or two neutron stars merge, releasing intense bursts of gamma rays that can last from a fraction of a second to several minutes. While these bursts are highly directional, if one were to hit the Earth, the consequences could be severe. The first thing that would happen is a sudden and intense burst of gamma radiation, which could ionize the Earth's upper atmosphere and potentially damage satellites in orbit. However, the Earth's atmosphere is an effective shield against most of the high-energy radiation from a GRB, so the direct effects on the surface would likely be limited. The most significant danger from a GRB would come from the high-energy particles produced by the explosion, which would travel through the universe at close to the speed of light. If a GRB were to occur within a few thousand light-years of the Earth, these particles could interact with the Earth's atmosphere and produce a cascade of secondary particles that would rain down on the surface. This could create a surge of ionizing radiation that could be harmful to life on Earth, and potentially even cause mass extinctions. However, the odds of a GRB occurring close enough to Earth to cause significant damage are quite low. GRBs are rare events, and most occur in distant galaxies billions of light-years away. Additionally, the probability of a GRB being pointed directly at the Earth is small, as the intense bursts are highly directional and would need to be aimed precisely at our planet. In summary, while a gamma ray burst hitting the Earth would be a catastrophic event, the chances of it happening are remote. The continued study of these enigmatic explosions is important for understanding the processes that shape the universe and for preparing for potential cosmic threats to our planet. Gamma ray bursts have been observed in distant galaxies using space-based telescopes, such as NASA's Fermi Gamma Ray Space Telescope and the European Space Agency's Integral mission. These observations have provided valuable insights into the physics of these explosive events, as well as their distribution and evolution across the universe. In addition to the direct effects of a GRB, the afterglow of the burst can also be observed across the electromagnetic spectrum, from radio waves to X-rays. These afterglows can provide information about the properties of the GRB and its host galaxy, and have been used to study the early universe and the formation of galaxies. Despite the low probability of a GRB hitting the Earth, it is still important to study these events and their potential effects on our planet. In addition to the direct effects of the high-energy particles produced by the explosion, a nearby GRB could also cause disruptions to the Earth's magnetic field and ozone layer, which could have long-term effects on the planet's climate and ecosystems. Overall, while the chances of a gamma ray burst hitting the Earth are low, the study of these events is an important part of understanding the universe and preparing for potential cosmic threats to our planet. It is worth noting that the likelihood of a gamma ray burst, GRB, hitting Earth is extremely low, as most of these events occur in distant galaxies and are directed away from our planet. However, there are a few potential scenarios in which a GRB could pose a threat to Earth. One possibility is that a GRB could occur in our own galaxy, relatively close to Earth. In this scenario, the high-energy radiation produced by the burst could damage the ozone layer and lead to an increase in harmful UV radiation reaching the surface. This could have serious consequences for life on Earth, including increased rates of skin cancer and other health problems. Another potential threat from a nearby GRB is the production of high-energy cosmic rays, which can cause damage to electronic equipment and disrupt communication systems. This could have serious implications for our technological infrastructure, including power grids, satellites, and other systems that rely on electronic communication. While the chances of a nearby GRB hitting Earth are low, the study of these events is still important for understanding the workings of the universe and the potential threats that could arise from cosmic events. By studying GRBs and their effects, scientists can develop better strategies for protecting Earth and its inhabitants from potential cosmic threats. In addition to the potential immediate effects of a nearby GRB on Earth, there may also be longer-term consequences for the planet and its environment. For example, a GRB could trigger the formation of nitrogen oxides in the atmosphere, which would deplete the ozone layer and lead to a long-term increase in UV radiation levels. There is also some evidence to suggest that GRBs may be linked to mass extinctions on Earth. Some researchers have hypothesized that a nearby GRB could have been responsible for the Ordovician-Silurian extinction event, which occurred around 450 million years ago and is thought to have wiped out up to 85% of marine species. While the exact cause of this extinction event is still unknown, a nearby GRB could have been one contributing factor. Overall, the effects of a gamma-ray burst hitting Earth would depend on a number of factors, including the distance of the burst, the direction of the radiation, and the strength of the burst itself.
I have a great time.